Thank you, everybody. First of all, I'm really honored to be here today, part of TEDx. And first of all, I'm the director of the Animation Visual Effects program at LSU Shreveport, which is a degree program we have there in both computer science and fine arts. And we also have a new program that we're starting in January called the DMC, the Digital Media Certificate Program, which is actually a new thing we're doing that's intensive and has some fantastic scholarships. And I just encourage everybody to come check it out if they have a chance. That's not what I'm talking about today. I'm not here to talk about the programs. I'm going to talk today about transformative technology and content tools and content creation in the real world. The world of 3D printing is essentially what we're going to talk about today. And how I've seen it evolve, how we've used it here in Shreveport at LSU, and the kinds of things I feel are on the horizon for us culturally and technologically in the future because of this technology. That's what's great about TED, is TED's about ideas that are worth sharing. And this particular technology is one that I was always fascinated with, and I got an opportunity to bring it to Shreveport through a Board of Regents grant. And it's been a lot of fun, very interesting technology to have, and we're still not done kind of figuring out great things to do with it. And I challenge anybody who's interested in this to come talk to us about it and come work with us. We're able to collaborate with almost anybody on these projects, whether it's commercial space or education space or what have you. So we'll talk a little bit about 3D printing. So next slide. So what is a 3D printer? Well, first of all, a 3D printer is basically a robot that extrudes a material or prints a material through a laser or a liquid or a powder. There's a bunch of technologies, even some carving technologies or wax-based technologies that are out there. Our printer is a plastic-based technology that works with an ABS-type plastic and a soluble support, which I'll get into a little bit more in a second. And that's how it works. You're going to see a video in just a moment. I've actually got a sample part here that's partially printed as well. This is actually a halfway printed plastic part with the brown material being a soluble support. That soluble support is really where the magic is in our machine, because it allows us to make parts that are fully articulatable. What that means is this part I have in my hand is not assembled. It came off the machine, was cleaned, and then was able to do what it's doing in my hands right now out of the box. As long as the tolerances are in the part, you can do that kind of stuff. Now, we don't do a lot of this at LSU Shreveport. What we do a lot of is actually content type models. So this model was done in digital sculpting software, which I'll talk a little more about in a second. This was done by one of my graduate students in an open source software. And this guy here, some of you may recognize, this is actually one of the early versions of Mr. Morris Lessmore. I like to call him Fat Morris before Morris got thin. But before he went over to Jenny Craig, Morris was a little bit rounder. And this model actually was made by one of my illustrious colleagues who's sitting in the front row here, Rafael. He was Caduto Mendola, in a program called Softimage, which is one of the big content creation tools. Now, so we're using a bunch of different tools to create the content that goes on this machine. These are some of the things you can do with it, but it goes beyond that. Next slide. So this is actually a video done by one of my alumni. This is actually printing a project for Moonbot. On our 3D printer, it's time-lapsed, obviously. And this was probably about a day or so, or a day and a half build time on the machine. And what you see there is the print head moving up and back and forth. It moves in X and Y, and the stage moves up the Z-axis or up the vertical axis on the machine, and it's on a plate, which is basically the build area. Our machine does a breadbox volume, so 8 by 8 by about 10. You can make larger parts by assembly, or you can send it out to a place that has a bigger printer if you need to. And you can see it printing both the model and the support material at the same time. And that's how it works. It has two nozzles on the print head. Again, this is just our technology, but it's commercial off the shelf from a company called Stratasys that makes the Dimension Elite. Now, this isn't the only machine of its kind in the area. There's a few of them around. There's some over in Ruston at Tech, and there's one just recently at BIPSI that does the same thing. But what's unique about what we do is we use content tools to develop the objects that go on the printer primarily. We do use the engineering tools from time to time, but most of the software that I work with and my colleagues work with and my students work with is a content tool. So that's what makes this kind of unique. And it's also led to some very unique partnerships for us with industry here in Shreveport-Bossier. And I'm going to talk a little bit about those as well. But that part right there is actually from a current project, so I can't talk about it. It's under NDA, and you can't really make out what it is, so we got clearance to use it because it's surrounded by support, but it is a character of some kind. And so the process is after you finish building the part, you actually snap it off the plate, and then you'll break away any of the larger chunks of the support material that you can take away without damaging the part, and then you put it into a tank of a strong solution. The solution washes away the brown material, and you're left with the part. Now, we can print in many different colors, but only one color at a time on our printer, but there are printers out there that can do multiple colors, multiple materials. You can do solid materials, you can do soft materials, you can do materials that have elastomers in them, and that's kind of what the finished part looks like right there. And we set up a time-lapse camera, and we actually added a light bar inside the machine to be able to do that. The machine has a light, but it goes out after a few minutes. So we rigged that up for a documentary on the project that we're actually working on with Moonbot, or worked on, actually, it's shipped. But go to the next slide. So these are some images of some of the things we've done with our printer. So we've been able to do some creation. We've been able to do some inspirational stuff. On the upper right-hand corner there is a commission that we did for a local pastor. It was modeled by my student who's holding that model in his hand, Ben Moss, in a program called Mudbox. Mudbox is a digital sculpting package. It's not an engineering tool. It's not a surface-based modeler like Maya or Softimage, but it's actually a tool where you grab a brush and you push the mud around like clay, digitally in 3 dimensions. And it's really, really intuitive because it has layers like Photoshop, and you can work with it very, very nicely. And there actually are some open source tools out there that do the same thing. This model that's actually the one Ben's holding in his hands right now, is the one in my hand, it's been cleaned, was done in a program called Sculptress, which is open source. So there are several different open source modelers you can get out there that can do these kinds of models. There are even websites where you can, if you don't have access to a printer, you can actually send your part off to someplace to get printed, like a service bureau. And there are companies you can turn up and do that. Other things that are in there, obviously, are some of the flying books from the fantastic flying books of Mr. Morris Lesmore. Now, our part of that project involved those books in the center image there. Those are molded from masters we made on the printer. And they were molded by the hundreds and printed and painted and put into the frame at the bottom. But what's unique about it is we took the models into Mudbox and added leather-type textures and weathering to the books that you could actually see on the book itself when you held it in your hand. We added detail and surface texture using a content tool on top of another content tool to create a physical object that was then printed, molded, painted, and then photographed, and then later CG components were added on top of that shot. So it's a very interesting blend of technologies. They used this technology in a movie called Coraline recently, and I think Frankenweenie also was a lot of 3D printing as well. They're able to do more facial positions for stop motion animation by using 3D printing technology. Other things up there, we did a trophy that was actually given to Stephen W. Lindsay, who was one of the last guys to fly the space shuttle. So we made a 3D printed shuttle specifically for him and handed it to him, and he was blown away by the fact that it was printed. So I got a chance to impress an astronaut, which was pretty cool for me because I've always been a big fan of astronauts myself. So another thing up there on the screen, on the upper left-hand side, is a medical device that we had a hand in helping to bring to reality. That's a tool that holds a device that looks into the human retina and has an app attached to it. And they brought us a concept and they said, hey, can you help us put this on the printer and kind of figure some things out? And we did that, and we were able to go through revision cycles. We used traditional CAD type tools to make that model. And then they took it to a manufacturing plant, and they cut tooling for it, and they manufactured it. And recently, I believe the company sold that off to another company for mass manufacturing. So that device actually heals people. So we've done quite a bit with our printer in a couple of years that we've had it, and it crosses over so many different areas, and that's been what's so very, very interesting. And it's been something that has been really cool to have as part of our program because it's both transformative and attractive to people that when they come to see the university. A lot of people never get to touch a 3D printer. Those of you who are here in the room, outside on the floor at our booth, we have a small 3D printer, which is actually about the size of a large bread box, if you will, and it prints a 5 by 5 by 5 area. It costs quite a bit less than the printer that we have at the university. Again, I'm not here to sell a product, but if you want to see a printer going, there's one a couple rooms away, and we're actually printing the trophies for the Game Jam here at DigiFest on it right now. It's running a print as we speak. Next slide. So 3D printing is content creation for the physical world, in my opinion. So if you want something in the world that is unique, that's yours, that you've designed, if you can master a tool that can make a model, you can make a physical object. That's pretty incredible for the average person to be able to do that. There are these printers that are out there that are very inexpensive now. Some of them are kits. Some of them you can buy off the shelf for $1,000 even. And you can make parts and things that go into your world and that are yours, that are unique to you. And that's going to change the world, in my opinion. You know, I often give the example of imagine if you could go to the store and you wanted to buy a motorcycle. You could have the entire motorcycle customized to your specific dimensions, your specific likes or dislikes, and they could manufacture the entire motorcycle using technologies like this, using CNC and rapid prototyping to your specifications. And let's say you had a bad day and you dropped the motorcycle down and it fell and broke. Well, they've got all the files. They can remake every single part for you on demand and build you another bike or build your replacement parts. So that's where this technology is going. We've got engineering-based modeling, which is, like, again, an example like this one here. We've got surface-based modeling, which is an example here. This was done with a surface modeler. And then we've got digital sculpting and in the open source world. Even the technology itself, the printers themselves, are actually available in the open source world. There's a printer out there that's actually open sourced. And a company called Weta Digital down in New Zealand, they do the Lord of the Rings movies, working on The Hobbit right now. They actually have taken the open source patents and they've built their own 3D printers that are on giant scale to be able to print parts for the movies on demand for what they're trying to do. So the technology is pretty open. You know, there's several different manufacturers that have patents on some things, but there's a lot of places where this stuff can be accessed by almost anybody. And it's pretty transformative in my opinion. Next slide. Now, if you add in the 3D scanner, it is Star Trek time. Okay? It's Star Trek time, straight up replicator. All right? You add that scanner, and all of a sudden, you can take an object, you can copy it, and you can print it back out. And that is, in my opinion, pretty transformative. Think about it this way. Jay Leno, for example, has one of these scanners and one of these printers, very similar. I believe he's upgraded recently, but he at one point had the exact same printer and the exact same scanner you see here, and they had a manifold off of Bugatti from, you know, it's a one of one. There was only one in the world, and this was the one, and the manifold blew out. He took the manifold off the car, put it in front of this scanner, they scanned it, they repaired the blowout, they put it on the printer, printed out the manifold, took it to a foundry, recast it in cast iron, machined the flange, put it back in the car, and it had the same serial number and all the same bumps as the original casting from Bugatti in the 30s. That's pretty amazing that you can use this technology to replicate something that was only made, you know, in a very small amount a very long time ago. And you know, that's pretty amazing. You know, we actually used the scanning technology, again, on some things that were sculpted. They were taken again into a 3D paint, a 3D sculpting package. They were cleaned up and modified and changed, and then they were printed back out, and they were used as parts of a project. And again, pretty amazing stuff. I also want to give credit where credit is due. That's actually John Skirman, one of my alumni, who's been very, very deeply involved in the 3D printing. He works at Moonbot Studios and actually acts sort of a liaison between us when we do 3D printing with them. And he's a very talented young man and very deeply interested in the printing process, and was somebody that I was very lucky to have a chance to work with for a while over at the university. Next slide. So I'm going to close with this concept. In the future, everything in the material culture is available on demand, customized to your unique specifications, and made mostly by robots. And that's really a pretty crazy idea, but we're very close to that. And you know, technology as a cultural force does two things. It makes things less expensive and more accessible. Think about the cell phone. Think about the automobile, think about the aircraft. All these things have gotten less expensive and more accessible over time. 3D printing technology, rapid prototyping, 3D scanning, on-demand manufacturing, dark factories, which are basically manufacturing centers that don't need humans in them. These are all going to be part of our world in a bigger and bigger way all the time. And we're going to see things happening in the 21st century revolving around the combination of these digital technologies with this robotic manufacturing that are going to change the way we live. And that's what I've got. If anybody has any questions?